Welcome to Ask and Learn.
Okay, so this question is about the rotational spectra of the molecule. Let's see the first question. The first question asks the bond length. And let's look at the question. The question actually gives us the rotational constant. B, right, equals to 1.92. And then we need to calculate the bond length. So the first thing we need to do is to write down the expression of the rotational constant, which you can check the book, equals to B equals to Planck constant over 8 pi square times speed of light and times the moment of inertia. And for the moment of inertia, right, the I also equals to the reduced mass of the molecule times the bond length. And the bond length is what we need to calculate. So now the question, the answer becomes very clear, right? In order to calculate the bond length, we first need to know the moment of inertia. And in order to know the moment inertia, right, we need to use this formula. So let's start with this formula. We can make some changes, right, from the rotational constant. Let's just write down again. The rotational constant equals to this. And we can just do a rearrangement, and we find the moment of inertia equals to the Planck constant over 8 pi square times the speed light and times the rotational constant. And now we can do the calculation. And one thing you need to be careful is the unit, because the unit of the rotational constant given use the inverse of the centimeters. But if you look at the expression of the moment inertia, they use meters. So the first thing you need to do is to convert the rotational constant unit to inverse of the meters. So for this one, you can do a conversion. It actually equals to 192 inverse meters. Now we can just plug in the numbers. So the Planck constant here equals to 6.62 times 10 to minus 34 and over 8 times 3.14 square, right, times speed of light, which is 3 times 10 to 8. And the rotational constant here, we need to use 192. And use your calculator, you can get the answer, which is 1.457 times 10 to minus 46. And unit is kilograms times meter square. Okay, so now we get the moment of inertia, right? And in order to calculate the bond length, another parameter we need to know is the reduced mass. So now we can then calculate the reduced mass. The reduced mass, mu equals to, check the book, the reduced mass equals to the multiplication of the two masses, right, over the addition of two masses, which here is two atoms. The first one is carbon, another one is oxygen, right? So let's just do M1 is carbon and its mass is 12 times 1.66 times 10 to minus 27 times the mass of the oxygen, which is 15.99 times 10, 1.66 times 10 to minus 27 over the addition. Let's just write down again for your convenience, plus the mass of the oxygen. And same, you have to use your calculator and be careful, and you will get the answer. The reduced mass of the CO molecule is 11.38 times 10 to minus 27 kilograms. And now, right, for this expression, right, we already know the moment of inertia, and we also know the reduced mass. Now we can calculate, right, the bond distance, which again we do an arrangement, right? The square of the bond distance equals to the moment of inertia over the reduced mass, and the bond distance equals to square root moment of reduced mass over reduced mass, and just plug in the number, right? We can 1.457 times 10 to minus 46 over 11.38 times 10 to minus 27. Use your calculator. Say you will find the mass. No, the bond mass is equal to 1.13 times 10 to minus 10 meters, and it's equal to 113, right, picometers. And this is the answer. And the second question asks about what is the position of the first two lines of the pure rotational spectra. So in order to do the answer, right, we need to first write down how to calculate the position of the lines. So here the position is a wave number position, right? If you remember, you can check the book. The position of each rotation levels equals to, right, the rotational constant times the rotational quantum number, right, and times the rotational quantum number plus 1. So the question asks two lines. One is first two lines. So we need to first define what is the first two lines. So the first line, right, should be the transition from the ground state, right, to the transit to the first excited state, which the quantum number is 1. And the second line is a transition from the first excited state to the second excited state, right? The quantum number changed from 1 to 2. In order to calculate the position of the lines, right, we need to first know the position of the energy levels for the ground state, the first excited state, and the second excited state. And now we can do the calculation. So for the ground state, right, equals to this formula. And in the ground state, right, the J, the quantum number equals to 0. So the ground state equals to 0. And the second, the first excited state. And this time, J equal to 1. right? So it's equals to 1 times 2, so it's 2 times the rotational constant, and this equals to 3.84 centimeter inverse. And for the second excited state, this time J equals to 2, right? So it becomes 2 times 2 plus 1, so it's 6b. And this equals to 11.52 centimeters inverse. Now we can calculate the position of the first two lines. So for the first line, the position is from the ground state, right? Transit to the first state. So we do subtraction from the of the ground state and first excited state, which equals to 3.84 minus 0. So it's 3.84 centimeters inverse. That's the first position, right? And the position of the second line is the energy difference, right, between the second excited state to the first excited state, which equals to 11.52 minus 3.84, and the answer is 7.68 centimeters inverse. And that is the first, the position of the first two lines. And the third question, to what transition do those lines correspond? And at the same time answers the same question we already know, right? The first lines, right, is from the ground state transit to the first excited state. And the second line is from the first excited state to the second excited state. And yeah, you can actually combine the second question and third question together and answer them together. And that's it.